Okay, this is really the final video already, yeah? Yeah, okay. Question 6. Question 6, right, is if you look at the question, you see a rectangular ABCD represents a vertical cliff face. So this part here, right, is like a vertical wall like that. So whenever they say vertical, right, it has to be 90 degrees with the ground. That's why this is a 90. They are very nice, they label for you. And similarly, down here must be 90, right? That means all this A, B, A, X, Y, B, all this, right, they are all on the floor. Okay? The red color one are all on the floor. Blue color one, right, is in the air. Okay? So I hope you understand this first. I just explained to you what it means, this whole thing. The bottom of the cliff AB runs from west to east. So you remember north, south, east, west, right? Oops. North, south, east, west. I try to tell you it runs from west, this western side, this western side, with the A, and then it go from west to east. Nothing one, nothing one. This one not say okay, nothing very important, or is it? If not important, then why they tell you? Okay, because one of you asked me, why they tell me this? This is very important. I'm trying to tell you this is very important. Why very important? Because just now I mentioned that this is like a 3D question, right? But then later you see, oh, they asked me for bearing. But in the question, they didn't even tell me where the north is. But they already told you that this one is west. This one is east. That's why this sentence is very important. AB runs from west to east. So this must be north. Do you follow? So north, south, east. So north, south, east, west. This is west, this is east. Okay. Now that you understand, we can start already. So a ship is in the sea at A. So there's this ship here lah. Then you check all the whatever they give you, right? Does it tally with the diagram? If it tallies, then it's fine. Okay? So I'm going to erase all this now because it's very confusing. Oops, I will just leave the north direction as it is here so that you know where the north is. Now, calculate the bearing of y from x. So where are you? You are at x. So you need to draw a north line at this x here, a line pointing to the north direction. Okay, you are at this x here. You look north. Alright, you turn until you see your y. So isn't this okay, let me try and draw a more accurate line. You should use a ruler and draw, okay? So sorry, I can't draw using a ruler here on the computer. Okay, so this you know is 180, right? Then do you know this? Do you know this particular angle here? Actually, this particular angle, because just now we mentioned, right, it's north, south, east, west. North, south, east, west, right? So all this must be 90, correct? Must be 90. So actually this is 90. Oh, but if this is 81, this must be 9, 9, okay? Yeah, so the bearing of y from this x is just 180 plus 9. Finish already. If you want, right, you can take 270 minus 81, because this part here is 81. Then the rest are 9, 18, 27. Okay, I hope you understand. Okay, now calculate the length of xy. Where is xy? Xy is here. Oh, so you see, when they ask you like that, right, you must you yourself must go and check, can I use this triangle to help me? Okay, so if I look at this triangle, is it a right angle triangle? If it's not, then you think of sine rule, cosine rule. So you see, do I have a friend? Very good, I have. Do I have a friend? Yes, very good, I have. So you can use the sine rule. Okay, this method, yeah, no good, this one no good, no good, no good, no good, Okay, you don't have to write all this, no need, Okay, so you should actually write like that first. Okay, what you want to find, you write here, which is xy. They write at the bottom, no good, no good. Why no good? It's always good to write at the top left hand corner. Then this one, you just multiply it away, and then it become it will appear at the other side. So xy is the friend with this sine 36 degrees. Okay, must remember to put the sine. Many of you in your homework you forgot. Then if this length, this must be length. So 24 over sine 81. Then your next step, right, is like that. 24 sine 36 over this. Okay, now I'm going to erase because the rest is all here. Okay, the rest is all here. So you don't use this one, you use this one. Okay, I'm going to erase this now. Okay, now done. Oh, done. We are done with part A, part B. Done, very good. What must we do after we are done? You must label. Okay, label the. Okay, this one I don't label already. This one. Okay, wait. I label like that easier. 9. Okay, and this is my north. Okay, this is 14.238. All right. Now let H be the shortest. What am I doing? I'm doing shortest distance from the ship to the cliff. Where is the cliff? They already told us just now that the cliff is ABCD. Okay? They told us already, represents a vertical cliff. So shortest distance from the ship to the cliff. Then I go and draw. I draw shortest distance is always a line, the shortest line from the point Y to the line AB, and where they meet, it must be 90 degrees. So now you see, should I use this triangle or should I use the other triangle? Now I'm going to use this triangle. Why? Because I draw here. I know this 90. I know, I know this 36. I know this 24. Okay, I can find this already. Which is the shortest distance. How? This is 90, so this is called hypotenuse, right? This is my angle, so this is called opposite. O over H, so it's sine 36. Okay, equals to opposite over hypotenuse. Then I so-called multiply by 24 both sides. I'll get 24 sine 36. Okay, which is, if you look at this, it's here. Alright, then they put to 6 fs, but you can just put 4, not 4, put to 5, okay? 4 also can, but I told you already, we a bit more kiasu, we put 5, Okay, then you round off to 3 SF. Now, after that, I'm going to label these, because I found it already, so I'm going to label it 14.13. Don't be confused, this refers to this line, okay? And this refers to this one. Okay, never mind, follow the accuracy. This refers to this one. This one refers to this one, okay? Yeah. Then now that you have updated your diagram, you can move on to the next part. The angle of depression of the ship when viewed from sea is 15. Angle of depression when viewed from sea is 15. That means sea must be at a higher ground, right? Yeah, which is true, which is true. Yeah, it's true. Sea, let's say you're standing here, right? You stand here. Then you look, right? You must look horizontal first. Then you look down at this ship, right? The angle is, what did it say? 15. So if this is 15 using alternate angles, the Z, this Z, right? This must be 15 also, no? Okay? You imagine that you are looking at this side, right? This line is like a Z, no? I mean, this line is parallel to this line. So this is the alternate angle. And of course, when you see from this side, this will be 90 degrees. Okay? Then now, what do they want? They want us to find the height of the cliff. Very simple one. It's always right angle triangle, got or not? Definitely have one, okay? So we see when we see from this side, can you see that let me erase this. Can you see that your YB is 21. Then this is a right angle and they want this height, right? And you see, I know that this is 15 can find already. You see why? Because this is opposite. Then this is adjacent. Then use tangent, okay? So I leave it to you. This one I think quite straightforward lah. Don't have to write this. Don't have to write this. We'll give it to you, don't worry. Okay, after you have found this, right, update your diagram. Very important. Very, 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 very important. Very, 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 very important. Okay, so now the last part is calculate the greatest possible angle elevation of the greatest possible value of the angle elevation of the top of the cliff when viewed from the ship. What are they talking about? They're asking you to find what is the greatest possible, this one no need angle of elevation of the top of the cliff when viewed from the ship. So where is the ship? The ship is here. Alright, you try to understand now. Wait. The ship is here, right? Okay, I tried. I want to show you this question and the diagram at the same time. Never mind, okay? You refer to this question on your paper. We want the greatest possible angle elevation of the top of the cliff when viewed from the ship. So where are you now? You are at the ship. Okay? So let's say the ship is here. Then the cliff is there, right? The cliff is here. So they're asking you, what is the highest angle that you must view in order to see the ship? Okay, I'm going to use this laptop to explain to you. Okay, so this laptop screen is like your vertical wall. It's like this: A, B, C, D. You understand? A, B, C, D. Understand? Okay, then this keyboard, right? This whole keyboard, your A is here, your B is here, your Y. Okay, Y is here your keyboard Y is here. But that, for simplicity's sake, can we just say that the Y is here? Okay, this object here. Okay, so ladies and gentlemen, can you see that when I turn it to the side, the side view, right? I turn it to the side. okay, okay, when I try to view at this corner here, when I try to view this corner, right? Okay, oh, this is the angle of elevation that I must have in order to look at this point on the cliff, right? Okay, if it's this point, it'll be like that. If it's this point, it's like that. If it's this point, it's like that. If it's this point, it's like that. Okay, you follow? Okay, so can you see that if it's this point here, right, it's this angle. Okay, but if it is the angle that is formed when it is looking at the nearest, you see, can you see how high up now the angle changed? Just now the angle was only like that, okay, but now you see, now when it's like that, right, not enough, not enough. Oh, I have to go up, some more, right? So the greatest angle of elevation will happen when you are looking at the point nearest to you. You follow? Okay, so I'm going back to the original screen already. Meaning to say, right, I hope you know what I'm saying. If you don't know, you ask me lah. Okay, meaning to say, it is here, no? Let me change to a blue pen. It is here. This is the point. Then immediately come down, right? This is a right angle. You know what I mean? It is where just now, okay, this is the red color line, this red color line, okay, then this blue vertical line, right, is from here go up to here, okay, then the imaginary line down is like that. Okay, so if I were to draw the side view, if I were to draw the side view, it will be like that. Like what? Like this. Wait, this is a cliff. Okay, this blue line, this is the blue line that runs from here all the way to the ship. Okay, and here to here is your, okay, let's call this point T lah. This one T, okay. This point here, the angle being formed by these two lines must be 90. Okay, and just now we already labeled. That's why you see, very important for you to label here. Okay, so they want this. Wait, what do they want? They want what? Oh, greatest angle elevation. Okay, so you already know this height, 5.6 something something. This height here is the same as this height here, what? Okay, because this cliff, everywhere here, the cliff, right, the height is the same. So AD also 5.6269. Okay, so this is 5.6269. So I can find this angle already, lor. Let's call it theta. Why? Opposite this one, adjacent. So tangent theta equals to opposite over adjacent. Finish. I haven't finished, sorry. You tangent inverse, then finish. Okay, okay, you go and look at the solution, there's somewhere here, there, same, same. Okay, and 1 dp. So that's all, thank you.